So let's talk about this problem. Before we can start talking about the transformations from the parent function, what do we have to know? The parent function. What is the parent function of this transformed function? Good guess.
Y equals the square root of x.
Y equals the square root of x. So basically we have to figure out what changes were made from y equals the square root of x. How many changes do you see? I also see 4. What's one change that you see? The negative? What's another change that you see? The 4? What's another change that you see? The 5. And the last change? -6. See, I see 4 changes. Okay? So think back to what we said on Friday. What does that negative cause the parent function to do? So if it's y equals the negative square root of x, what does that cause that parent function to do? Reflect. Now I've heard a lot of people say reflect, but does it matter? Can we just say reflect and that's it?
It does matter.
It does matter, right? How many different things are you allowed to reflect over?
2.
2. It's a little bit more than 2.
Well, 2 in either direction.
So like an infinite number of ways that we can reflect? Yeah, absolutely. Okay? So we need to specify relative, right? We need to specify what we reflected this over. X-axis. I had some people ask me earlier, do we need to write this down? So my answer is this. A non-sarcastic answer is this. I'm not writing this down because I don't know how to do it. I'm writing it down because I'm not sure if you know how to do it. So I would like you to write it down, please. Fair enough? Fair enough?
Fair enough.
Yes, ma'am. Excellent. Thank you. Okay? What about number 2? It would look like y equals a times the square root of x, right? A multiplier out in front of the square root. What does that a cause this to do? Tell me first, is a inside or outside of the square root? It's outside. If it's outside, what kind of change is it?
It's a lift, right? It's a shift.
It's a vertical change. Okay? A is a multiplier. So not only is it a vertical change, but it is a vertical stretch or compression, right? If it's a stretch, what's true about the value of A? A is greater than 1. Good. If it's a compression, what's true about A? Very good. A is it's greater than 0 and less than 1. It's between 0 and 1, right? Yes, sir.
What happens if it's negative? Oh, sorry.
Yeah, if it's negative, it's a reflection, right? So once we take care of the negative, we don't pay attention to it anymore, do we? Okay, good question. So what about the third part of this? Wouldn't it look like y equals the square root of x minus h? Okay. Is that inside or outside of the parent?
Inside.
It's inside. So it's a horizontal change. In this case, it's a horizontal shift. Now, horizontal shifts can be tricky for some people if you let them. Okay? This says x plus 5. If it says x plus 5, which way are we horizontally shifting this? To the left. Okay? That's the part that can be tricky if you let it. Look at the actual equation. The actual equation is x minus h. This has to read x minus something. x minus what? Negative 5. Which direction is negative 5? To the left. Okay? Now some people just see this as x plus 5 and they think it's got to be the opposite of whatever that is. Am I okay with that? Yes? As long as you understand the math behind it. The math behind it says the formula is x minus h. This needs to look like x minus something, some h value. For this case, x minus some h value would have to be negative 5. Negative 5 means we go to the left 5. Okay? What if it said x minus 5? What value does h have? If it says x minus 5, what value does h have? 5. Right? Because x minus h is the formula, and h, if it said x minus 5, 5 would be, h would be 5, which means we'd go to the right 5. So some people think, well, whatever this is, I just go opposite of what I think. If it's inside. Okay? Any questions about that? Now, when we write this, we have to give ourselves a directional word. We can't just say horizontal shift 5. Because it could be left or right? We don't know unless we say a directional word right here. That's important. Okay? And our last possibility is what? It would look like what? Y equals the square root of x plus k. Is the k inside or outside? Outside, so?
So it's a vertical compression. No, it's a horizontal compression.
It's a vertical change.
Yeah.
Okay.
It's a stretch.
It's a shift.
Shift.
Look at the action taken by the vertical stretch or compression. What action is being taken by this number right here? It's being multiplied. What action are both of these numbers taking? They're either being added or subtracted. If the numbers are being added or subtracted, it is a shift. If a multiplication is happening, then it's either a stretch or compression. Now, some of you tried to put on your homework a horizontal stretch or compression. Have we talked about that yet? No, it's not time. We're not ready for that yet. Okay? So, even though it might physically look like a horizontal stretch or compression, you don't know what that looks like yet as far as the equation goes. Okay? Any questions about that? Okay. So, if we were going to follow all these rules going back to this original problem, tell me, what are we going to write down? First of all, reflects over the x-axis. Second of all, what? What are we going to write second?
Vertical stretch by 4.
Vertical stretch by a factor of 4. What does this word imply? Multiplication. Okay, that'll help you remember what it's doing too, won't it? What about the third thing? What's the third thing that's happening? Horizontal shift. Which direction? To the left 5. And one last thing. Vertical shift down 6. This is our answer right here to how that changes from its parent. Okay? So that's the hardest one you'll have to do. So every other problem on your homework tonight should be easier. Fair enough?